Right, so we have some different types of logic gates. I'm gonna just list all the types you need to know at this level. You need to know, why is this so big? You need to know a NOT gate, AND gate. Typically, we write it in capital letters. So NOT, and you can give me any others, Justin, since he was already in school,
Or
right? So we have NOT, AND, or yeah, and where's the other one? It is some kind of similar to AND, but it's actually opposite to AND,
NAND.
right? And what about for OR?
No.
Okay, cool. So let me start off with NOT. I said this topic is logic gates. A logic gate, you can think of it as something that would look at the inputs and it would decide whether to turn on or turn off, depending on the inputs. So this topic is logic gates. Right, so we're going to start off with a NOT gate. This is what a NOT gate looks like. Right? A NOT gate takes one input and just simply inverts it. That's all it does. But you need to remember what it looks like. That's the key thing. So Aliyah, I need you to be copying down. We have a lot of work to do. By the end of this month, I want to be done with the syllabus so that when we start to do practice questions, I think in preparation for the exam, like we good. So I need you to be taking down these notes fast. All right.
Okay.
So I know you're chewing, but lucky. So this is what a NOT gate looks like. It just has one input. Notice there's one input, meaning that there's one thing going into the logic gate. So this is a symbol for a NOT gate. So I'm gonna do a truth table for it. So what is a truth table? You need to know what a truth table is. A truth table is a table that has the inputs and it will show you the output for the respective gate. So Aliyah, what a NOT gate does is whatever the input is, it inverts it. So let me show you what that means. Right, so Aliyah, here what I was saying, right? A NOT gate, you can think of it as an inverter. So if my inputs, so when we're dealing with gates, so Aliyah, try to think of binary. Do you know what binary is? Have you ever heard the term binary?
Yeah.
Okay, what is binary? It comprises of what two numbers?
Um.
What is bi? Bi means what? Bi is what number? Bi.
I.
Bi. Okay, taking too
And
long. Bi is two. Two. So when we're talking about bi, we're talking about either a one or a zero,
okay.
right? So binary. Logic gates deal with binary signals, either one or zero. So Aliyah, one would correspond to a system being on, and we think a zero would correspond to. If one is on, where zero correspond to?
Off.
Yeah. So a NOT gate has one input. So if the input is one, what do you think the output could be? If I say it's an inverter, it's something that inverts the input.
Zero.
Zero. And if my input is 0, then my output is 1. Simple. And that's the truth table for a NOT gate. Very simple. The hardest part is to remember the symbol, what the symbol looks like. That's the hardest part. Once you can do that, you'll be fine. All right, let's move on to the next one. So the other type of gate we have is a AND gate. Now, the thing with an AND gate is that an AND gate accepts two inputs, right? And this is what an AND gate looks like. All right. So earlier, I'm going to do a big truth table for AND gate now. So an AND gate, the difference between an AND gate and a NOT gate is that an AND gate could have two inputs. And you can think of an AND gate as a multiplier. So whatever my input is, it will perform the operation of multiplication. So let me give you an example of what I'm talking about. So earlier, how much inputs an AND gate have?
2.
Right. So we're going to say input 1 and we're going to say input 2. So we're going to have input 1, input 2, right? And then we're going to have the output. So you hear what I'm saying? I am saying that an AND gate acts like a multiplier. So if my input, so let me go through all the cases. We can have an input as 0, 0, 1, 1. I can have an input as 0, 1, 0, 1. So guys, anytime you're going through all the options at this level, this is how you would put it. So for input 1, it would be 0, 0, 1, 1, and for input 2, it would be 0, 1, 0, 1. This is how you put all the possible cases, right? So Aliyah, if my input 1 is 0 and my input 2 is 0, and I'm saying and the AND gate is like a multiplier. What is 0 by 0?
0.
Okay, so basically what this means, it means that if the both inputs are off, then the output will be off. Okay, let's check out here now. So 0, 1, what would the output be?
0.
So what I mean, so what I means is if something, imagine you have two things, and these two signals control another signal. So what this means is if one of these signals is off and the other one is on, then the final result will be off, right? So look at what's going on. Imagine I have two inputs controlling a final output. If both of them was off, then the output will be off. If one of them off and the other one on, the output is still off. What about here? If one of them on and the other off, the output will
Will
be
be off.
right. Last one, if both of them on, then
The output would be on.
yes. And that's the truth table there for AND gate. So what do you think would be the opposite of an AND gate? See if you could figure it out. I'll give you a hint. Check out this gate. This gate is a what? So Leah, what does the NOT gate do? What does the NOT gate do?
Is an inverter.
Right. So to figure out the opposite of an AND gate, it would just simply be the AND operation, but inverted. So that operation will be represented as NAND. You just simply put
Okay.
an N in front of the and you see how the NOT gate have a little circle there at the
Yeah.
end? It's the same thing we're gonna put
Oh,
on.
okay.
So you notice that anytime you have a NAND, you have a NAND, you have a NOR, it's the same symbol as the others. It's just that you're putting a little circle and you're negating the output. I'll show you what I mean by that. So a NAND, so the easiest way to think of NAND is just the opposite of a AND. Right? And Alia, based on what we're seeing so far, from the NOT situation where it was an inverter, it had this little circle thing at the end. And as the same thing we're gonna apply over here. So we're gonna apply our circle to right here. Right? And look at what's gonna happen, right? So Alia, 0 by 0 is,
0.
what's the opposite of 0?
The opposite of 0.
Right. Anytime you put the little circle thing at the end, that means you're gonna invert the result you get. So
Okay.
our AND gate, so our NAND gate is just like our AND gate, but you're inverting all of the outputs that you would get for our AND gate. So
Okay.
if
So
if
it
you're
could
gonna
be
get 0, you teach it as 1. 0 by 1 is,
0.
but and then
But
invert it,
1,
right? 1 by 0 is 0, invert it, that will be 1.
1. So 1 by 1 in the NAND gate, it could be 0.
Right, because it's the same thing as the AND, you're just inverting it. So notice it's
Okay.
just instead of 0, 0, 1 is 1, 1, 0.
Yeah. Yeah.
Right. Okay, the second to last one is OR. Then you have a OR gate. And you can think of a OR as a adder. So you're doing binary addition, right? And the OR gate looks something like this. It looks just like an AND gate. The only difference is it has like a curve. Hey, Kiara, you ever do this in schools yet?
Hi, yeah,
Okay, cool. Kiara, what's your plan?
nothing.
You alive?
Yeah, you?
Yeah, I good. Someone sick.
Yes, for some reason, mocks come around and I get sick. I don't know, testers always get me sick for some reason.
So CSEC gonna get you sick too.
I hope not, I will cry.
Cool. So this is the symbol for OR gates. So Aliyah, how much inputs our OR gate has? 1 or 2?
2.
2. I'll look up it on everything after, right? So listen to what I'm saying. Our OR gate acts like an adder. If my input 1 is 0 and my input 2 is 0, I add 0 and 0, and that'll be what? What is 0
0.
plus 0?
0.
Okay, what is 0 plus 1?
1.
1 plus 0?
1.
1 plus 1?
2.
Those are 2.
1.
Counting in binary.
Okay, so 2. Wait,
No,
no, 1. 1.
1. Yeah, 1.
Okay.
We, again, logic gates deals with binary signals. Like, I mean,
Okay.
binary, strictly binary, binary addition, binary multiplication. We're just strictly dealing with that, right?
Okay.
Cool. So I want you to make a guess. If the opposite of and was NAND, what do you think the opposite of or will be?
Um, no.
Yeah, no. Very creative. And how you think the symbol for no will look like?
Um, it could be the same thing as or, just with the circle.
Yeah, they're real creative, huh? They're real
Mm-hmm.
creative. And that's it, we finish with this topic. Okay, we're not finished. We had to do some with examples. We more or less finished. Very easy topic. Right, so Aliyah, no is just literally the opposite of or. So I mean 0 plus 0 is 0, and the opposite of 0 is,
1.
right? So I think you get the idea. That would just be 1 0 0 0. Understand?
Yeah.
Okay, cool. So I would like you all to copy this down. So these are my tips. Anytime you see NAND or NOR, just know it's the opposite of the original one. If it's NAND, the opposite is the opposite of AND. If it's NOR, it's the opposite of OR. And the symbol is just the same symbol with just a little circle at the in the front. Right, so we'll do a couple examples and then we'll move on. So I'll do one example with you guys, and then I'll give you all one to do by yourselves. Justin, I see you sent me everything already.
Yeah.
I wonder if your notes from school.
Nah, my notes from school, they right next day, but here's my lessons book.
Oh, okay, okay.
More
All
one
right.
for school, more scrappy.
Damn. Or
So,
Justin, if you put any exam, you're not gonna get full marks, because that's not a table.
yeah.
I'm being serious. If you put a, you're not gonna get full marks because they're gonna say
Now, I had a, okay,
there's a table.
wow, wow, fix it.
Not to be political here, right? But any earlier, like how things going in Pinal? I not in Pinal. I currently in Arango and I see in real UNC thing, boy. Real thing. How things on that side?
Nothing. Nothing.
Nothing at all.
Nope.
Um,
They don't care about penal again.
all right, so as soon as I have this copy down, just let me know. We'll do a sample question and then I'll give you all one to do by yourself.
I forgot to ask if you have any paper ones for physics,
I have all
because I
I
do
have
some practice from Monday.
I have everything for physics. Everything. Like everything.
Because we supposed to get a maths paper one today, but then the printer also we get it Monday now. So it's three tests we have Monday.
Okay, well, I'll send you the just remind me after class, I'll send you the sample, like the question pool, like all the possible questions. I have all the possible questions I could bring.
Because we teacher in school, he say how physics paper one, like it don't repeat. So I don't know.
Real
I
funny,
don't know.
funny. That extremely funny. That
That's
made me
what he tell we at school today. So I was like, I watch he like if you know what he's talking about.
That's the biggest lie I ever heard in my life. Man go
'Cause
lie,
I know most of the papers is repeat. So I was like,
man go lie to all this. So
I
you could
mean,
ask
it's
Desron.
rocky.
You could
It's
ask. Do
rocky.
you remember Desron?
Yeah.
You could ask him. He writes it, and he got two in the first try, and he do that in 3 months. It was everything was repeats, man. Everything was repeats. You know what them teachers? I mean, you know what them teachers be lying to all this, so you know. I have no idea. That's crazy. They be doing too much. So as soon as I have this copy, don't remember, no?
I have it already. So
I know you have it. I just waiting on the others.
On the second to last one.
All right. Justin, what do you think about the setup, like?
ah,
What do you think about the setup?
really does.
Yeah, I had to pay in the box.
That's okay, good.
Eh?
I'm sorry, good.
I should send you a video on it on full volume. It's be shaking everything.
Yeah,
Like the you see the four speakers on top of my desk?
yeah.
That is move. That is move out of this. Everything is move.
Because I have one in my room I know, but it's not nothing fancy. It's a whole Logitech system.
Oh,
Three three small speakers like this over this, about that size, and then the bass speaker like right here.
okay, okay. Oh, good. Right, so Alia will just let we know where's the code. Red or
And
yellow?
the last one. And the last one. Sorry.
You hear what I ask you where's the code? Yeah, yellow or red?
Oh,
uh,
who you voting for?
Carry that information. Definitely not the UNC or the PNM. I feel like if we want to see change, we can't just keep voting for the same parties or one of that. Nothing will happen.
Yeah. My last drawing, it kind of weird. I try my best to.
Ah,
So,
let's see. Let's see what you come up with. You submit?
who's the?
You.
No, I just on the last row of the table. Hold on. I'm going to send you it now, right?
All right. Okay, cool. So let's move on to a question. Question. All right. So typically, we don't usually say input one and input two, although you could say that. We typically assign a letter to it, so either A, B, C, or D. So let's look at a question. Okay, so Aliyah, this is what the things actually look like. So you ready? Yeah, Aliyah, tell me if you're ready. Can I hear?
Okay, why not?
All right, so first things first, let me just figure out what each logic gate is. Do you remember what the first, remember this? Do you remember what this one is?
Um, that's a or the or gate.
Right, what's this one?
Which one? That's the and
Nope.
no, the not.
Not?
No,
No, you
this
know
one,
what?
the not.
You know what I mean? And it's be like, all right, not, you have to not. That's a not gate. Hey, Justin, you don't find this like an JBL logo? Like if you
Yeah.
right, so this is a not, and this is a what?
And
Yeah. So let me show you how we gonna do this, right? First things first, we're gonna have we're gonna drop a truth table. Now this truth table wouldn't have like input one, input two. You're gonna have like A, B, C and thing, right? You're gonna have A, B, C. All right, so let me start, right? So Aliyah, how much inputs we have here? I want you to look at the question. How much inputs you have at the start, at the first stage?
you have two inputs.
Two inputs. I'm not saying two inputs. Saying more. I
Oh,
have two input
three.
going to the OR, and I have an input going to the NOT. So I have three. So I'm gonna say A, B, C, and then I have how much outputs?
Three.
Right, I have D, E, and F.
Yeah.
Now this is the part where I'm gonna lose you, right? Potentially lose you. Do you remember how it looks like if you have two inputs? So if you have two inputs, there's a specific format in which we need to write it. So if we how we starting off then? Uh, if we starting off with 1 0 1 0, and then for B, what we gonna write?
Um, 0 1 0 1.
Say that again.
0 1 0 1.
0 1
Wait,
0 1.
wait, wait, wait. Yeah, yeah. And
Let me see. So for
yeah.
OR gate, but actually for OR gate, look at what we typically have. For OR gate, you
0,
have 0011, then 0101,
0. Oh, okay. So 0011 and
right?
yeah.
Right? So
Mm,
technically, it shouldn't matter. The order shouldn't matter. Once you get the same result, I'll show you what I mean. So
okay.
going into the OR gate, right? Going into the OR gate, you have, so I'll have 0011, then
0,
I will have
0,
what?
0101.
Right? And go into C, what we're gonna have?
C could be 0111.
No.
No.
Yes, it's 0111. Look
Oh,
at C. Where is C going into? C is going into the NOT gate.
yeah. So that could be
So
1
you can say
0.
110.
D could be
But here what? And again, this is the part where I think I'll lose you. C only takes, now C could only take one input, either a 1 or a 0. But notice that for the sake of A and B, we need to run through all the possible outcomes. So like 00, 01, 10, 11. So since that is the case, for C now, I also have to put 4. So I'm going to say 10, 10.
yeah.
All right. So let me continue from here. So A and B is going into what gate?
A and B.
Mhm.
That's going into the O gate.
Right. And it's going to produce which output?
D.
D. What does our OR gate do?
What was that?
What does an OR gate do again?
Is a adder.
Right. So 0. So this is what we're going to do. A way to figure out C, right? For now, focus on A and B. So if you add 0 and 0, that'll be,
0.
what to put next?
1
Mm-hmm.
1
Right.
1.
Right. Let's move on to E now. So what's going into, so E is the output for what input?
Is the output for C.
Right. And C went into the NOT gate.
Yeah. So that will be 0
Yeah.
1 0 1.
Right. And now F would be, so
Um,
F. So the inputs for that would give you F
is
is D
E.
and E, D and E. So D
Oh,
and E going into the AND gate to give you F. So we're looking at D and E. What does the AND gate do again?
the AND gate is a multiplier.
Yeah, the AND gate is a multiplier. So we're looking at D and E. So 0 by 0 is
0
mm-hmm.
1 by 1 is 1.
Yeah.
1 by 0 is 0.
Mm-hmm.
And 1 by 1 is 1.
Yeah. Well, let me just confirm that this is correct. I want to make sure that the order doesn't matter.
Mm-hmm. I
Is
coming
it
back,
correct?
right?
All right. Wait, guys, give me a second. Aliyah, Kristen, I see you just now joined. I'm sorry to hear about what happened. But you feeling okay now? A bit? Okay. That's better than no. So a win is a win. Okay, so everybody understand this question? Justin, you understand it?
Yeah.
So let me run through one more time. So first things first, you recognize what each gate is, right? That's the first thing you're gonna do. So the gate that A and B is feeding into is an OR gate, and OR gates you add. Now C is going to a NOT gate, so you just invert the input. Now D, which is the output, look like you're on your phone. You can multitasking there. Yeah. Right? So yeah, Justin. Actually,
Yep.
you explain it to me. You explain it to me.
Me?
Yeah, you.
Um, well, A and B will be the inputs for the OR gate.
Right?
C is the input for the NOT gate.
Yeah,
D, well, D is the output from A and B, but is the input to the AND gate.
right.
C, well, E is the output from the NOT gate, which is the input to the AND gate.
Right.
D and E is the input to the AND gate, and F is the output to the AND gate.
Yep, perfect. So I'm gonna change up this question a little bit, slightly. So I'm gonna give you all ABC, and I want you all to figure out the final output for D, E, and F. So I changed it up a little bit. I want you all to figure out, I want you all to complete this truth table. So I gave you all the values for A, B, and C. Try to finish it out. Justin, see you
Yeah.
looking at something. I see you mesmerized. You look like you're on TikTok there. What?
No, what off?
Ali, are you there? You were seeing how focused Justin was?
Mm-hmm.
Justin talking to a little birthday.
I feel so.
Yeah, a little boy named Parvati or some Indian girl.
Oh, probably from right up the hill convent.
Probably.
What are you blushing?
Wait, is this a conversation I need to have with your mom? Hey, I had to talk to Miss Shanta about this.
Hmm.
Man face turning pink. You know, like how for breast cancer awareness month, everybody's wearing pink. I
Mm-hmm.
feel like Justin face support in that month. I think it is. Anyways, yeah, what? Sometimes in the question, they will give you the inputs, right? And tell you to find the outputs. So I gave you all the inputs. So I'm saying A is 1010. I'm saying that B is 0110, and I'm saying that C is 0110. So try to figure out D, E, and F. Let me see what you all will come up with. Take take 3 minutes. It's real easy. It's one of the easier topics. Right, so go now. Yeah, so Justin, I hope you tell Parvati that you're gonna do some work and you put on the phone on there and you start working on the question. Ali, are you working?
Yep.
Okay, cool. All right, so how things going, guys?
I gained through. I think. I don't know if you're correct, but I tried.
Okay. Okay. So waiting, guys. The time is up. All I do was I just change the inputs. That's all. It's the same principle, it's the same concept, it's the same everything, nothing changing.
I finished. I just drew any diagram.
Okay. Well, if you finish, just summary the answer. The answer is the thing I want to see. Okay, so I see that Aliyah and Justin are the same answer. Right? Let me see if I get correct. So Justin, let me go. Again, it's the same concept. A and B, you add in it because it's an OR gate, right? So D would be 1 plus 0, which is 1. 0 plus 1 is 1. 1 plus 1 is 1. That'll be 0. E is just the opposite of C, so that'll be 1, 0, 0, 1. And F would just be you're multiplying D and E. So 1 by 1 is 1, 1 by 0 is 0, 1 by 0 is 0, 1 by 0 is 0. So yeah, both are legally correct. Are they good? Let me know if you're feeling okay.
Yeah.
So Ali, are you good?
Yeah.
Right, so typically in the question, they will give you the inputs. They will tell you what the inputs are. You just need to figure out the outputs. So I'm going to give you all a next question. Right, so Alia, you have your diagram copied down already?
Yeah.
All right, next question. All right, guys, I want you all to try this. Try out it. So the inputs I'm going to give you guys are, I think, actually I could give all the same inputs. Why not? Right, so I gave you all the inputs. Try to figure out what F would be. Right, but actually, let me not say anything. I want to little bit this question entirely by yourself. Entirely. Oh, I didn't get anything from Kiara. Kiara is being awfully quiet. Kiara and Kirsten. Well, I know both of you are not really feeling well, but still try something. Aliyah, you getting through with this question?
I tried.
Try it. So let me ask you a question, Aliyah. What are the inputs for this? And what is that exactly? There's a and, no, not. What is that?
That is a no.
Yeah, and what is the inputs for that?
0110.
Wait, tell me the letters.
Oh, B and C.
Yeah, I thought you would get confused by that because of how it go into over here. But yeah, correct. B and C. Yeah, so keep going. Okay, I see Justin send me he answer. I'll wait until the rest of them send me the answers. So Alia, Clara, Justin. Alia, are you done?
Yeah, I'm gonna send it now.
All right, Clara and Kristen, are you all going to attempt the question?
I'm doing it right now.
Okay, cool. And Kristen, you let me know what's going on with you.
I didn't draw the diagrams yet.
That's okay. I just want to make sure you get the answer. Okay. Okay, so it's a good sign. I see that Justin and Alia have the same answer, right? I just waiting on Kiara. So Alia, you like this topic?
Yeah, it's quite easy.
Yeah, it's too easy.
That's okay. They should bring this.
Okay, we'll see. Alia, I think Parvati tell Justin that she going to sleep.
That's why he looking so.
Yeah.
I don't think he realized we talking about him.
Nah, he only studying that girl.
Parvati, yeah.
What did the girl name? Hmm. What are the chances that the girl name is also Alia?
Kabi, I doubt.
Hmm. He's so mesmerized. He probably looking at she's sleeping or something. You know how it does go. You know how it does go.
Hmm.
They're probably on a video call and he looking at she's sleeping and
Yeah.
stat or something saying watching Bay sleep. So now he have a room with me.
Yeah.
That's crazy.
He still don't realize.
What?
Oh, when love hit your body.
Yeah.
Ooh, just send the invite you to the wedding.
What?
Not
I
your
don't
what?
know.
What
I don't
your
know what I'm talking about.
what? Yeah, Kiara waiting.
Reggie, I'll send in it the image. Or
Okay, let me see if you're correct. So it looked like Justin and Ali are correct. Let me see what you are gonna do. Okay, Kirsten, attempt is all I'm asking. Try something. Okay, Kiara, you get a different answer from Aliyah and Justin.
oh,
So let me see who wrong here. Right? So first things first, let me identify what each gate is. So this over here is a what kind of gate? What kind of gate is this?
oh,
Okay, what about this one?
no,
What about this one?
NAND,
Yeah. So let me go. Let me see how the badnesses go. Right? So they gave us A, B, and C. So we need to figure out what D is. So Kira, help me here. So is either Kira wrong or is either Aliyah and Justin wrong? So let me see. So Kira, so the inputs A and B go into the OR gate, and the OR gate does what? What does it do to the inputs?
um, what?
It adds the inputs. So we're gonna add one and zero. One and zero is what?
1,
One and zero is one. Continue. So we're looking at A and B right now,
yeah,
right? So one
then,
plus zero is one, then zero plus one is,
and 1,
right? One plus one is,
1,
zero plus zero is,
0.
right? Let's move on to E now. So what's the input that will give you E?
Is the,
So what are the inputs that will give you E? What is going to that gate to give you E? So Kira, what
B, B,
B and so we're looking
C,
at it,
C, B and C,
B and C. So we're looking at B and C. right? So you're dealing with a NOR gate.
Oh wait, I do it wrong. It will be if it's the opposite of the or, then B and C. That means the first one in E will be one end.
Right? Because 0 plus 0 is 0, and the opposite of 0 is 1. And 1
Yeah,
plus 1 is 1, the opposite of 1 is 0. 1 plus 1 is
yeah, and then the 1
0,
plus 1 is 0. Yeah.
right? And then the last one will be from the inputs D and E. So
Um, it that will be
what I mean, and means to multiply. So you're multiplying and you're just inverting it. So 1 by 1 is what?
0.
1 by 1 is 1. Inverse of that is 0.
Oh wait, yeah.
0 is 0. Inverse of that is 1. 1 by
Mhm.
0 is 0. Inverse of that is 1. 0 by 1 is 0. The inverse of that is 1.
Yeah.
Aliyah and Justin, y'all got this?
Yeah.
Sorry, my bad. I do it wrong.
Okay,
Yeah.
nice. Well, we have some work to do there, Kiara. Okay, let me try this question. Let me stop sharing the screen real quick. Aliyah, check Justin now.
He real studying she boy.
I never see more, yes? I feel Bryce could be the same way, you know.
For real, yeah.
But it's a good thing. They go treat their girlfriend good.
Mm-hmm.
They might be a little stupid, but at least they treat them good, you know.
Yeah.
All right, so let's move on to a more advanced question. And that, guys, that's it. That's it for logic gates. That's it. Right, so then we can move on to radioactive physics, and that is it for the whole syllabus. We're done. Granted, it's kind of a long topic, but we nearly there. We nearly there. Let's go. All right, so let's do this question. Aliyah, um, Aliyah and Justin, I want to let you help me. Aliyah, what you call Justin?
Kabir.
What?
Justin Kabir Balchan.
Government name.
Yeah.
That's a girl good night now, boy.
Tell she in class when you're done. Wakes
Ah,
you
of
up.
course.
But
Don't
remember,
forget he have the
remember he took
backup.
out two films.
Exactly. He have the
Hey,
backup too.
Ah,
wait, that one is Priyanka, the other one is Parvati.
hey, no.
Oh God. Anyways, let me go. So Aliyah, read the question then.
An electric kettle is connected to an alarm that sounds whenever the kettle is switched on and the lid is left open or the water level is below the heating element. The figure below shows the circuit that controls the electric kettle's alarm.
Okay, so let me understand what's going on, right? So an electric kettle is connected to an alarm that sounds whenever the kettle is switched on and the lid is left open or the water level is below the heating element. Okay, this question a bit tricky, but we'll figure it out. So we need to write down the conditions. So Aliyah, they're saying that lid sensor, 1 is open, 0 is closed. power supply, 120 volts is on. I mean, yeah, 1 is on, 0 is off. Level sensor, 1 level below heating element, 0 level above heating element. Okay, okay. I'll let me read the question back one more time. So they're saying an electric kettle is connected to an alarm, right? So it's connected to an alarm that sounds whenever the kettle is switched on. So first of all, the switch must be on. So it must be on. So for the alarm to turn on, if the alarm is on, was that 0 or 1? If the alarm is on, guys, if the alarm is on, that's a
It
0
could
or
be
1.
a 1.
Okay. So for that condition to be met, it sounds whenever the kettle is switched on. So the kettle must be switched on, right? So the kettle must be switched on, right? So this must be a 1, right? So it's switched on and the lid is left open. So the lid is left open. So the lid is left open. Or the water level is below the heating element. If the water level is below the heating element, this could be what?
1.
1. Okay. So we have 1, 1, 1. Okay. Then that's going into logic gate A, logic gate B, right? Then I go into another logic gate and I go into sound the alarm. Okay. The figure below shows the circuit that controls the electric kettle's alarm. All right. All right. So guys, let me try to understand what's going on here. We can figure this out. So Justin, you will help me with the top one, and Alia, you will help me with the bottom one. So Justin, now we go. So we have, so they say in here, it sounds whenever the kettle is switched on. So it must be on, and the lid is left open. So Justin,
Yeah,
yeah?
yeah.
Right. So if I leave the lid open and the power on, that would, what do you think that would be? That would be 1 or 0?
1.
That would be,
Wait,
that would be
yeah.
1. So what would I have to do with 1 on 1 to get 1? Multiply, add. What do you think I would have to do?
Multiply.
I would have to multiply because 1 by 1 is 1. So what kind of logic gate do you know is does multiply?
Um,
Which one is a multiplier?
no.
No, no.
And
Wait.
And is what I'm looking for. You see the girl in the head, he got things straight. Is 1, is 1. I put any notes, I put that in the notes. When this, I tell you straight, I get straightforward. I tell you, and is a multiplier. And is the multiplier. That's all that. So to get to 1, you'd have to multiply 1 by 1. So A is a AND gate. Okay. Now we need to figure out B. So Aliyah, they are also saying that the the alarm sounds when it is turned on and the lid is left open or the water level is below the heating element. So it has to be turned on or the water level has to be below the heating element. So Aliyah, are you there?
yeah.
If we want this alarm to ring, right?
Mm-hmm.
Let me think of all the possible reasons we might want the alarm to ring. Think of a possible reason. Why would you want the alarm to ring? This-
Um,
Imagine you have a kettle. Why would you want the alarm to ring?
To know when the water being finished heated.
Yeah, but we don't
Like
have that
when,
criteria over here. The criteria we have is the lid open.
so when the lid open,
Okay, yes. And now ask you a question. Will the alarm go off if the power supply is off?
no.
No,
So it have to
no.
be on,
It have to be on.
right?
So let me run through that logic again. I want to make sure they understand this question. This is a very important question. So we want the alarm to come on, right? For the alarm to come on, they are saying it sounds whenever the kettle is switched on. So we know it has to be switched on, right? It has to be switched on. If it's not switched on, then it would produce our output of what? Tell Malia. If the power supply is not on,
It
then it
gives
will produce our output of
0.
right. So even if the lid sensor, so Aliyah, I really want you to understand what we're going on, right? So Aliyah, even if even if the lid sensor is on, which is one, so even if the lid sensor is one, if the power supply is zero, will the alarm sound?
No.
No. But if the lid sensor open and the power supply on, will the alarm sound?
Yeah.
So what gate are looking like? One and zero is zero. One and one is one. What gate are looking like?
1 and 0 is 0. 1 and 1 is 1. The and,
Yeah, they're looking like and then.
yeah.
Okay, so we figure out that one. That's the one I did with Justin. Let's try to figure out this. It's the same concept. If the power supply is off, will anything come on?
No.
Right, so if the power supply is off, it don't matter if the level sensor is one, will the alarm ring?
No.
All right. But if the power supply on and the level sensor is below the heating element, and that's a bad thing, if it below the heating element, that what I mean about the water in the kettle.
If it below the heating element.
Yeah. You have an electric kettle?
Yeah.
Okay, if and you just fill water in it before you put it to boil.
Mm-hmm.
If the water level below the coil, it heating up any water?
No.
No, Aliyah. And the whole purpose of the electric kettle is to submerge the coil in water because the coil is always get hot, you know. So
Uh-huh.
like you have
Like,
water in the kettle and the coil
yeah.
is heat up the water. But if the water is below the coil, which is the heating element, will the water
It
get heat up?
wouldn't. No, it wouldn't.
And so the coil will get extremely hot and it will burn down the house.
Mm-hmm.
Do
So
you
it
want
would be
that?
no.
No. So once the power on and the sensor is below the heating element, which is one,
Go off.
the alarm should go off. And if the alarm on, that is one or zero?
1.
One. So Aliyah, what gate is this?
Um.
What gate is this? Look at the logic. 0, 1, 0, 1, 1, 1.
Does the and gate?
Yeah, there's an AND gate again. Because if you have 0, 1, 1, the only way you can get 0 is saying 0 by 1 is 0.
Yeah.
Okay, so Aliyah, Max, that question, right? What criteria must be turned? What criteria must be met for the alarm to go off? Like what have to happen for the alarm to go off?
The lid sensor have to be open.
No, the lid sensor could be open, the level could be below the heating element, and the alarm still wouldn't go off. Why? Just want to see if you can answer that. What have to be on here? What have to be one for the alarm to go off?
the power supply.
Yeah, because earlier, if the power not on, how the alarm will go off? If your phone dead, how the alarm will go off? You understand?
Yeah.
Right? So this is our AND gate, this is our AND gate. And now earlier, let me just assume that yes, it have power. So if it have power and the lid sensor open or the level sensor saying that is below the heating element, and in both instances you would want the alarm to go off.
Yeah.
Let me say that one more time. I'll say it one more time. If if the lid open, so we automatically
Okay.
assume the power had to be on, right? Power on. If the lid open,
Yeah.
if you leave the lid open, one, and you leave the level sensor, I mean, and what I'm saying, and the level of the water is saying that it below the heating element. In those both instances, would you want the alarm to go off? So you leave the lid open, number one,
Mm-hmm.
and the water is below the heating element. Are both of those things bad?
Yeah.
Yes, yes, yes. Both of those things are bad
Mm-hmm.
because you don't want. Okay, if you have a kettle, why would you want to leave the lid open?
Yeah.
Right? You wouldn't want to
Yeah.
do that. And the second thing, if the water evaporate and it below the heating element, it will burn down the house. So that's another red flag.
Mm-hmm.
So, and you want the alarm to come on if either of these scenarios happen.
Yeah.
So what logic would that correspond to? Think about it. Try to think about it. They cannot sell it out in the question.
Um.
So if I want the alarm to come on in either situation, what that will be? So I want you to figure that out. So
Okay.
I want the alarm to come on in either situation.
Right.
Either. What I mean either? What I mean?
In both.
In both, yeah. So if you leave the lid open or the water is below the heating element, the alarm will go off. Will the alarm go off in any other instance?
No.
No, read back the question.
An electric kettle is connected to an alarm that sounds.
They cannot sell it out in the question, but I really wanted you all to figure it out the hard way. But they really give it out in the question.
When the kettle is switched on.
Okay, yeah. Well, we saying that had to happen, right? The kettle had to be on. We understand that, right?
Yeah.
So we get a one. So it had to be on. We understand that.
Mm-hmm.
But what I'm saying, right? So, Aliyah, let me just say the kettle on, right? So it's a one here, and you
All right.
don't leave the lid open. So that's a zero. Chances are on gate, we'll get over here.
Um. 0.
Zero, okay. Let me just say again, it on, but the water level below the heating element. That we one. There's an AND gate.
1.
So why could be over one here, right?
1.
Do you want the alarm to come on?
Yes.
Why you want the alarm to come on in this instance?
Wait. Because the level below heating element.
Yeah, right? So that could be one case. So then a zero and a one, a zero and a one, and a
Oh.
one.
Okay, that's what you mean.
Yeah.
Okay.
And let me look at another scenario. Let me just say you have power, the level below the heating element, and you leave the lid open. So then this go be our one, this go be our one. So according to this, you leave the lid sensor open and the heating element below the water level below the heating element, do you want the alarm to go off?
Yeah,
Yeah, because what happened? Why the alarm going off?
because the lid sensor open and the water level is below the heating element.
Right? Let me just say it have power. Now the level above the heating element, but you leave the lid open. This could be what?
1,
This could be.
and that could be 0.
But do you still want the alarm to come on?
Yeah,
Okay. So what logic gate would that correspond to? So even if, so what we're
1 and
saying is, so again, we want it to come on in either or, in either instance. So we want it to come on if I leave the lid sensor open, or the sensor below the heating element, or I leave it open and the water is below the heating element. So what logic gate is that?
the OR gate.
Yeah, that's the OR gate. It give away because
Yeah,
is OR is literally OR. It's gonna come on like a way to read the question, right? The question give it away. I didn't want to say that at the start, but the question did give it away. Read the question. It's saying an electric kettle is connected to an alarm that sounds whenever the kettle is switched on and the lid is left open or the water level is below the heating element. They give it away there. So, Aliyah, for this to work out, the power supply has to be on. So if the power supply is on, then the power supply is on and the lid sensor could either be closed or open. So the logic gate is AND. Same thing for this one. Now, Aliyah, let me show you what we're doing, right? Let me show you something. If you leave the lid open, the lid sensor is gonna pick up that. Granted, you have power, and you're gonna get a 1 over here. So if I get an a 1 by x, what I mean? Remind me what I mean. I mean that Aliyah, if I get an a 1 by x, what I mean?
that means that the lid sensor,
I mean that the lid open,
oh, right, the lid open and the power supply on.
right? So we get 1 here at x. Let me just say the water is above the heating element. Do you still want the alarm to go off?
Yeah,
Yeah, because we do.
the lid sensor still open. No,
Yeah, the
the
lid's still
power
open.
supply on.
Yeah, the lid's still open.
Right.
So the alarm still had to go off.
Yeah.
So what I'm trying to say is either one gonna cause the alarm to go off. That or that will cause the alarm to go off.
Mm-hmm.
Again, let me just say you close the lid, but the water level below the heating element. So if you close the lid, X is 0, but if the level below the heating element that's 1, but you still want the alarm to go off, so that's 1. Let me just say that you leave the lid open and the water is below the heating element. Do you want the alarm to go off?
Yeah.
Huh?
Yeah.
Why is it you're not confused? It obvious here. You leave the lid open and the water below the heating element. That's a hazard or that good?
That's a hazard.
So if it's a hazard, why what the alarm to do?
Go off.
Right, so one. Where's the one situation you wouldn't want the alarm to go off in? Try to figure
When
it
the
out.
lid when the lid sensor when the lid closed and the water level above the heating element.
Right. And this describes the behavior of a what gate? So it comes on when the lid open or the level
Um,
sensor is below the heating element. That's all
the
way to
OR
figure it
gate.
out with our OR gate. So I'm gonna show you the trick one more time. Look at what it said. They say it comes on when the kettle is switched on and the lid is left open. So this has to be an AND gate because the only time it works is if the power supply is on and the lid sensor either open or close. You understand, Alia?
Yeah.
So this over here will only work, the alarm will only work if the power supply is on. So if that is the case, then the power supply has to be on. If the power supply not on, then the alarm will automatically be 0. That describes an AND gate. Because in an AND gate, for the output to be 1, both of them and has to be on. So Alia, tell me if you're confused. Have any confusion?
No.
No? Okay. So Alia, explain it to me. Let me see.
Okay. Um. Wait. Okay. So in the question, they say that the electric kettle is connected to an alarm, and it sounds whenever the kettle is switched on, and the lid is left open, or the water level is below the heating element.
Right, that's all I want to read. So explain.
So um the first the first logic gate
Mm-hmm.
is the AND gate,
How we know that? How do we know that?
because in the question they say that the lid is left open and the water level is below the heating element.
Well, that's not what they said. They said the lid is left open or the water level is below the heating element. It does sound like you fully understand it.
No, I understand. I just don't know how to like explain it. Like,
Then you don't understand it. If you understand something perfectly, you'll be able to explain it. I understand I being harsh, but my teachers used to tell me that as well, and I never believed them until like I was actually in his shoes. So like if I don't fully understand something, I can't explain it. So Leah, I want you to try to wrap your head around it. If you need to take some time and think. What condition must be met over here for me to get an output of 1?
1 and 1.
Explain to me in terms of logic, like in terms of the situation.
The LED sensor must be open and the power supply must be on.
Right, that's it. The lid sensor must be opened and the power supply must be on for you to get an output of 1. That
Right.
describes the AND gate. Nice.
Okay.
Because
Oh,
because
okay,
it's
okay.
very obvious, eh? For
Yeah.
AND gate, both of them have to be on for the output to be on. Because
Sweet.
the lid sensor and the power supply have to be on for it to be on.
Yeah.
Right. With our OR gate, either one has to be on. So that one or that one has to be on to give me 1.
Yeah.
Yeah, I think you understand it.
Yeah.
Right? So let me do the truth table now. Right, let me do the truth table really quick. Right. So let's go, guys. So we know that A is an AND gate. So if A is an AND gate, then whatever we have for L and M, we're going to do what with what were the inputs? We're going to do the inputs.
Multiply.
We're going to multiply it, correct? So tell me what we're going to put for X.
0, 0, 0, 0, 0, 0, 1 and 1.
Right, so you see for yourself that the only time you're gonna send a signal to the alarm is if it gets in power, number one, and the lid open. That's it. So both of them have to be met. So and that one and that one. Right? Why now? Justin, do why? Alia, it look like the girl want to sleep.
Yeah.
What?
Nothing, nothing. Let me go. Movements. Why? Figure out what why is.
Well,
Figure out the output.
why is that AND gate too, right? So um inputs for that is M and N, right?
Yeah.
Right. So 0 0 is 0,
Wait,
0
what?
1
What is
0.
that? It turned out zero. What the hell? Alia, I can't be the only one that see that. What? How that work? I didn't even know how that happened. What? I don't know how that happened, but that's real weird. What? Anywho, let me move on. If it happen, it happen. So yeah, Justin, it's basically the same criteria. For it to be on, it must be getting power, and and the water must be below the heating element for it to be on. Right? What about
Right.
Z? So Justin, do Z now.
C.
Yeah, do Z.
Uh, V is OR gate.
Okay, Justin, let me see if you understand this. Why am I saying that Z is an OR gate? Well, not Z, but before Z. Why am I saying that C is an OR gate?
Ah,
Alia, let me see.
good question.
Good question.
I understand A and P, but not too much C.
Okay, Justin,
Oh,
a kettle, right? If you have a kettle, you think leaving the lid open is a good thing?
no,
You think the water being below the heating coil is a good thing?
no,
So in either one of those instances, would you want the alarm to go off?
yes,
Yeah, so if you leave the lid open, you want the alarm to go off?
yeah,
Or if you leave, or notice what I'm saying, or if the water level below the coil, do you want the alarm to go off?
yes,
If both of them, if I leave the lid open and the water below the heating element, do I want the alarm to go off?
yes.
When is the only time the alarm wouldn't go off?
When it close,
And
when the level like above
yes. So what kind of relationship that represent? You
or
write it down here. So we have 1 0 1, 0 1 1, 1 1 1, and the only time is when both of them is zero. That's our OR gate. That's what
yes,
you,
okay.
the other way you could think about it is it on if the lid sensor or the level sensor giving you one. Or. So yeah.
Right.
So Z is or. So how you gonna tell me what to do?
0 0 0.
So it's or, so we add. Remember,
Yeah,
always add it.
yeah.
So we're gonna add X and Y. 0 0 0 0 0 0
1
1.
1.
Yeah. Just confirm. Yeah, most believe that's the answer. Yeah, we correct. Excellent job, guys. We just don't do a very hard question. I don't think it was hard, but it looked hard. So that's like excellent. They'll get figure that out. Right. So before we finish class, I want to take like a 4 minutes break. Take like a little break. We just not finished with our whole topic. We don't usually finish with our whole topic in one class, but we did. So big up on yourself. Take a little 4 minutes break, and we're gonna come back and just do this first page. Right? So the next class, we could hopefully finish radioactive physics. and we could organize for the crash course, and I could hear from Malia what's good dates for that, right? Aliyah, you're coming to AdMats tomorrow. We have to finish
Yeah.
kinematics.
Okay.
Gotta finish kinematics, probability, and statistics still. We'll see how we're gonna do that, right? But come,
Same
make
10
sure you
o'clock.
come to class.
Yeah,
What is
no,
it?
I come to class.
Okay, good. 10 to
For
12.
10, right?
10 to 12, yes.
Okay, yeah.
Right? I know that 8 o'clock thing wasn't working out at all.
I don't think, yeah, no. I wasn't in art maths class when you was doing the 8 o'clock.
Regardless, it wasn't
Right?
working out. That
No,
was
I
way
feel like
too
that,
early.
that would be too early.
Yeah, that's right. So take a little 4 minutes break, guys. Go get some more water. We'll do this first page. I'll introduce you all to the radioactive part of physics. I'll start class like 15 minutes late anyways. Right? So take a little break. Aliyah, wait, look like Justin doing it.
Probably still studying she.
And you know that meme like where the guy pulling out the petals saying like she loves me not.
I don't think so.
You don't know what I'm talking about?
No.
It's probably because he's like girl. I sure Bryce know about that. Like it is you'll be like, she loves me not. She loves me, she loves me not. Justin, you know what I'm talking about? Like in them Indian movies and then like they go have like a rose and they go be like remove any petals and be like, she loves me not. You know what I'm
Yeah.
talking about? And like whichever and whatever
But the last petal, however, equal last says the answer, apparently.
yeah. You see Justin know the thing. I now realize Justin playing with Lilo. No, that's Stitch.
That's Stitch.
I see it by Lilo. That's Stitch. Ooh. Anyways, I'm not about all, yeah. Take off 4 minutes. I go and get something to drink. Somebody supposed to play a rap BB song day. He was on the phone. Way. Pharmacy.
No, I know. No, take it off.
I'll be back. Justin, you listen to some hotline bling there or what?
Huh?
Like you're listening to some hotline bling.
Nah.
Hmm. Yeah, I find you real blushing on thing. No gonna lie, like I being serious. I find like you real blushing on thing. Tetris have you blushing bad boy. Here we back at it. All right. So I'm gonna call upon Aliyah. Aliyah, read the topic. Well, Aliyah going to eat some curry. All right, Justin, I want you to read the heading.
Um, Physics Section E, Atom Physics and Radioactivity.
History of the atom.
History of the atom. J.J. Thomson theorized and discovered the electron. However, he believed that an atom to be a cluster of positive and negative charges that he termed to he termed the plum
Pudding.
pudding model. However, scientists named Ernest Rutherford and Niels Bohr later theorized and proved that the atom had to have a center of positive charge. James Chadwick discovered the neutron. Two scientists named Hans Geiger
No. Geiger.
or Geiger and Ernest Marsden assist Rutherford in developing the structure of an atom that we know today. They performed an experiment known today as the what's his name again?
Geiger.
Geiger Marsden experiment or gold foil experiment.
You ever hear about the gold for the experiment?
Nah.
No. Nah.
Mm-mm.
So you had to know the plum pudding model, and you need to know the gold foil experiment. Like these are things that you need to know. So I want you all to copy down the history of the atom.
What a question on this come for mock exam. I didn't know what to do because we didn't finish these things in school.
Pressure.
And I think that question was about 6 marks.
Extra pressure.
The
Pressure.
first part was 6 marks, then 3 marks, and 2 marks.
You know, if I didn't have UE, I would have stay up tonight. I mean, I'd finish this. But unfortunately, I have like 60 pages. I have real work to do. Like, watch this. It not look
Hmm.
it not looking that packed, but it is packed because
Back to back.
yeah, 3 exams back to back. And that's like just now. That's like just now. Oh my god.
Six to go.
I soaking it in. I still soaking it in. This is Monday. Wee. Nah, boy. Killing me, they're killing me. Yeah. I'll stay up and finish this, but can't do that. So I'm going to just draw the plum pudding model over here. Well, I mean, I just got send it on the chat. I just sent it on the chat. That's all I'm gonna do. So
I just hoping physics come easy.
physics is always easy.
Well, the kind of questions I see them bringing for mock exam, like,
Don't worry, physics is always easy. Right, so I have the plum pudding model there for the crash course. We're gonna do a oh, I'm gonna rail past papers. Rail past papers. Like probably never see before. Right. So under history of the atom, J.J. Thomson theorized, not terrorized, making the man sound like a terrorist. Right? J.J. Thomson theorized and discovered the electron. However, he believed the atom to be a cluster of positive and negative charges that he termed the plum pudding model. So the plum pudding model is just a ball with positive and negative charges in it. That's pretty much it, which looks like this. Well, that's not really the proper diagram on the chat. I'm just gonna draw something here real quick. So underneath, so here what? I want you all to insert the diagram over here. I want you all to insert the diagram for the plum pudding model over here. So you're gonna put the diagram over here. So you're gonna put the diagram right there. Right? So in the plum pudding model, they have a bunch of positive charges and you have the same number of negative charges. If you draw 5 positive charges, you need to put 5 negative charges. So you're gonna have the negatively charged particles, that's called the electron. And he believed that instead of protons, it had just positively charged space. Right? So this is positively charged space. Cool. So when all I finish, somebody notes. Aliyah, I trust that you're there. Kiera, Kirsten.
Yeah, I come back.
All right, nice.
We just writing up to the first paragraph
So we're
or the
gonna copy
whole
down
thing.
this whole page, right? It's not much. The diagram will take the longest. But what I want you all to do is I want you all to copy down up to here, and I want you all
Okay.
to draw the plum pudding model. What it looks like is it has equal number of positive and negative charges. He believed that it had electrons, and instead of protons, it was just a positively charged space.
Okay.
Right, so Justin, in the diagram, you do the diagram good this time, right? So that's the plum pudding model, and just notice that if you put 5 positive, you need to put 5 negative, right? So cool. So after you have that copy down, then you're gonna say, however, scientists named Ernest Rutherford and Niels Bohr later theorized and proved that the atom had to have a center of positive charge, right? So you copy down all that. Okay, so nice. Aliyah, you need to put the labels, right? So by the negative, you're gonna say negatively charged particle, which is an electron, and in the general space, but positively charged space. Justin, did you finish copy down however scientists, etc. this thing here?
Almost.
All right.
I'm not finished.
Okay, nice. Aliyah, you'll just let me know when you finish. Right, Justin, in the meantime, you can copy down the diagram. So yeah. So you need to know the Rutherford's goal foil experiment by heart. You need to know the observation and the interpretation.
That diagram going to be hard to draw.
Yeah. I could do a simpler diagram if all you want. So don't worry, don't copy it down. I can
I
do a
want to try. I have to try.
all right. It have a much simpler diagram.
I finished with the note. I don't know how to draw that diagram.
So you want me to show you the easier diagram.
Please.
Okay. We will have Mr. Justin. He could do the combinated diagram. I'm sure that's how it's done, right? Right? So in this experiment, you have a radioactive source. So let me observe what's going on. So you have a radioactive source. You have a piece of gold foil, and you're firing. So the radioactive source will emit alpha particles. So um they decide to use a radioactive source that would produce alpha particles. So you have the alpha particles, and wait. So Justin and Aliyah, you're doing chemistry, so you should know how a atom does look like. Most of the atom is actually what? Starts with E, not electrons. Most of our atom is actually what? So if I draw the structure of our atom, so this is the structure we know of today.
Mm-hmm.
Right? And over here we have the protons and the neutrons.
Neutron.
Right? And over here we have the valence electrons.
Right.
Most of the atom is actually made up of empty space. All here. Was all here.
It empty. That's
Yes,
empty
empty
space.
space. So what it's saying was, so this is what it's saying, right? So Justin, I want you to pay attention. So what it's saying was, so you first need to understand alpha particles. Alpha particle behaves like a proton. An alpha particle in nature is a positively charged particle. So what happened was most alpha particles would have traveled through the foil undeflected. And this is because most of the atom is empty space, right? So they cut a very, very thin sheet of gold foil. And Justin, what is all matter made up of? What is all matter made up of?
Atoms.
Right. And atoms, this is what the atom supposedly looks like nowadays. Most of it is empty space. So what we see in here is that most of the alpha particles pass straight through. Right? Most of them pass straight through. You see that? You see
Yep.
that?
Yep.
Okay. Some alpha particles are deflected by small angles. The reason why is because the nucleus is positively charged, as is the alpha particle. So let me ask you a question. When you was doing magnets, a positive and a positive would what? Like if you have a north pole and a north pole, would it attract or repel?
Repel.
It would repel. So so this is what we go on, right? If you have a particle passing through the empty space, it goes straight through. if you have it passing through the proton, what would happen is, since it has the same charge, it would deflect, right? Everybody with me? Let me know if you guys with me,
Yeah.
right? So, Alia, you there? Alia, let me know if you're there.
Yeah.
Right, so Alia, what's saying is, since most of the atom is empty space, most of the alpha particles will go straight through. Some of them would pass close by to the proton, and as such, it would be deflected. And some of them, if it hit the nucleus directly, it would just get reflected right back. So that's what happened. So that's what we come up with the fact that an atom is made up of a nucleus. Because when some of the alpha particles hit the nucleus, it would be repelled straight back, whereas some would be deflected by small angles. So you okay with that, right? Yeah, no.
Yeah.
Okay. So I'm going to do the simplified diagram here. Right, so this over here, this is our lead box. Right. Right, over here we have a radioactive source. So it have different types of decay. Anybody that would have done radioactive physics, you would have noted that there's alpha decay, gamma decay, and beta decay. So the radioactive source that we want to select, we want it to have alpha decay, right? Right, so we have a thin sheet of gold foiled over here, right? So Aliyah, this is easier to draw.
Yeah.
Okay, cool. Right, so this is basically it. Let's put the labels. So this over here, this is a thin sheet of gold foil. Trying to be really specific. You can see that the detector is actually a circular fluorescent screen. Right. So I'm putting the observation first. So this is the observation. Right? And the interpretation. Right? Just on how the complicated diagram coming along.
It looked better in my head.
Oh, that's hilarious. Yeah, we need some more space for this.
My diagram kind of tiny because yeah.
Oh,
Um, if after the diagram, this is all?
Yeah.
Okay. I had to leave class
Yeah.
when I finished.
Yeah,
Was it?
that I wasn't gonna keep all your back longer. This is after the
Okay.
diagram, does it? Next
Okay.
class we will continue where we left off. Right, so that's it. That's the goal for the experiment there. Right, so yeah, how to see you drive. I'm really excited. Right, so as soon as I finish, Salma, the diagram. Aliyah, that is performance.
Thank you.
But okay, yeah, that could be.
I know, yeah, it's real tiny, cause that was like that was all the place I had on the page. Sorry.
That's okay. So yeah, you could leave now. Next class, I'm gonna show you what we're gonna do. So next, we basically finish with this page, right? Next, we gotta do subatomic particles, the three types of radiation, cloud chambers, radioactive decay. Yeah, we nearly finish. Finish
Okay.
next class.
Okay.
Toodles.
Bye.
Bye. Yeah, Justin, you finish the diagram?
Almost, I just finished labeling.
Oh, okay. All the girls leave. I tell one person they can leave, everybody bust out. Wait.
I don't finish, but it kinda jumble up, but it's understandable.
Okay, well, let me see.
And during this simpler one, the other one didn't come out as I expected.
Okay, that diagram, you need to extend the arrows. So you say we touch the detector.
No, I accepted.
And if you're saying that most of the particles travel straight through, then what are pointing to? I'm talking about here. Watch these particles here. Them particles they travel straight through. So that's why I'm referencing. So you need to make sure and show that
Oh, yeah. I see what you mean.
because those traveling straight through. Then some of them getting deflected, some of them getting completely deflected back. Yeah, you need to point to those specific locations,
Yeah.
right? So fix up that and send it back to me. But that is it for class today. Right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pages again. Okay. All right. And then we could work on past paper questions. All right. So yeah, man, that's it. You have a blessed night. Thanks for coming to class today. I thought you wasn't coming, because normally you just run real early. But it's a good
Now I
thing.
end up, how I end up sleeping away. I end up sleeping away, and then I realized, oh God, I forgot to have lessons.
Hey, boy. You have a blessed night. Take care.
You too.